All right, now we're going to take a look at how to graph linear inequalities when they're written in standard form. Just like when we looked at linear equations in standard form, there's a different way of graphing the line than how we graph slope-intercept form. So here's how we do that. First thing we want to do is graph the boundary line, and to do that, we identify the x-intercept and the y-intercept, just like we did with graphing standard form equations. It's a couple of simple, quick divisions to find those x-intercepts and y-intercepts. We'll review that with some examples. Then for the type of line to draw, it's just like what we saw before. We want to draw a solid line if our inequality contains the solutions. In other words, if it has that little equals bar underneath the inequality symbol, we draw a solid line, just a regular line. However, we will draw a dashed line if it's one of our strict inequality symbols that do not contain the equals bar underneath it. So if it's just a less than sign, we draw a dashed line. If it has less than or equal to, then we would draw a solid line. Next thing we want to do is shade the half plane that contains the solutions. And when it's in standard form, we can't just use the less than shade below, greater than shade above rule. That only works when it's in slope-intercept form. When it's in standard form, it's best if we test a point. Pick one point somewhere on the graph that's on one side of the boundary line. Okay, it can't be on the boundary line. You have to pick something that's off of the boundary line. So a point that works really well, as long as it's not on the boundary line, is 0, 0. It makes it really easy to check and see if it's a solution, because all you're going to do is basically turn the variables into zeros. So multiply by 0, add the zeros. It's just going to become 0 when you do that. And we'll see that with an example. If when you plug 0, 0 into the inequality, if it ends up being that ordered pair is a solution, we shade whatever side of the boundary that point was. I can't say if it's above or below, but it's on that side of the boundary line. That's where all the solutions are if 0, 0 happens to be a solution. However, if 0, 0 is not a solution, your test point is not a solution, you shade the opposite side of the boundary line because that's where all the solutions are. They're either on one side or the other of the boundary line. So let's see what that looks like with an example. So here we have x plus 2y is greater than or equal to -4. So just a reminder, for finding your x and y intercepts, we're going to take the constant term, -4, and divide it by each of the coefficients. So when we divide by the coefficient of x, which is just 1, we will get, let's see, the x-intercept will be -4 divided by 1, or -4. Okay, so the x-intercept is -4. So on my graph, I know that my line has to go through that point. For my y-intercept, we're going to take that -4, divide it by the coefficient of the y term. So my y-intercept is going to be -4 divided by +2, which is -2. My y-intercept is -2, so on my y-axis, I place a point right at -2. For my type of line, I use that inequality symbol. It's greater than or equal to. So we've got the points on the boundary line are solutions. So that means we want to show that with a solid boundary line. Just a regular boundary line. See if I can get that to go through my points okay. That's not too bad. Extend your line all the way across the graph because we have to shade one side or the other. So if we test a point like 0, 0, we can see that 0, 0, or the origin, is clearly above the line. It's not on the line, it's on one side of that boundary line. So that's a good one to test. So I take my inequality, which was x plus 2y is greater than or equal to -4. And when I plug my zeros in for x and for y, notice how easy these calculations are. 0 plus 2 times 0. Well, 2 times 0 is 0. And then 0 plus 0 is 0. So we're just testing this inequality. Let me rewrite that. That's kind of small. 0 is greater than or equal to -4. If it helps, think about your y-axis to determine if that's true or not. is 0 greater than or equal to -4? Well, yeah, 0 is greater than -4, so that would be true. So what that means is the origin, 0, 0, is a solution. So we want to make sure that that is the shaded side, because that's where all the solutions are. All the other ordered pairs on that side of the boundary would also be solutions. So all the solutions are on this side this time, the side that contains 0, 0, because 0, 0 was a solution when we checked it. Number 2. All right, let's kind of do this the same way. Let's start with finding the intercept so we can put the boundary line in place. We'll check to see what type of boundary line we want to draw, and then determine if 0, 0 is a solution or not, so we can tell which side to shade. So for my x-intercept, I want to take, again, 4 divided by the coefficient of x, so 4 divided by -4. 4 divided by -4. Let's see, that's just -1. My x-intercept is -1. I can plot that on my x-axis. My y-intercept, let's see, I want to take 4 and divide it by the coefficient of y. So 4 divided by 2, which is just 2, positive 2. My y-intercept's positive 2. Let's see, type of line. I have a greater than symbol, but notice it's not equal to. So for the type of line, I want to draw a dashed line. Remember, I only draw solid lines if I have the or equal to as part of the inequality. So a dashed line, let's go to my straight lines, make sure I have arrows on both sides, and right about there. Splits my graph into 2 sides, 2 half planes. One side contains all the solutions, and I want to shade that side. The other side contains no solutions, and I want to leave that as unshaded. So we want to test a point, and it does look like 0, 0, the origin is clearly on one side of the boundary line, so that would be okay to test with my inequality. So -4x plus 2y was greater than 4. So when I plug my zeros in, just like we saw last time, it's basically going to make the entire left-hand side be 0, because anything times 0 is 0, and 0 plus 0 is 0. So I can kind of just skip to the end here. I know what's going to happen. So I have to ask myself, is that true? Is 0 greater than 4? So on my y-axis, is 0 greater than 4? No, it's not. 0 is actually smaller than 4. So this is a false statement. So that means 0, 0 is not a solution. So that ordered pair is not a solution. So where are the solutions if the origin is not a solution? And hopefully you guessed that right. All the solutions then are on the other side of the boundary line. Okay, not the 0, 0 side. It's over here instead. We could confirm that if we wanted to pick any ordered pair and test it. For example, we could pick a -3, 1 and test it to see that it's a solution. And when we plug it in like we did here, we'd get a true statement. And any ordered pair on this side would give us a true statement because those are the solutions. One last example. 2x minus y is less than or equal to -4. So for my x-intercept, I want to take -4 and divide it by 2. 4 divided by 2. And 4 divided by 2 is positive 2. My x-intercept is 2. I make sure to plot that on my x-axis. For my y-intercept, it looks like I want to take 4 divided by, remember that's a -1. So 4 divided by -1 is -4 on my y-axis. So I make sure I plot that down there. All right, type of line. If we look at our inequality symbol that we had, it's less than or equal to. So that means that all the points on the boundary line will be solutions, and we show that with a solid boundary line. So I can draw a regular solid line that goes through those 2 points. Let's see if I can get that. There we go. And then I just have to determine what side to shade. Remember, one side of my boundary contains all of the solutions. The other side has no solutions. And I want to shade the side that has all of the solutions. So let's test a point. The origin 0, 0 is clearly on the, I call it the left-hand side or upper side of this line. But when I plug that into my inequality, let's see, 2 times 0 minus 0, well, that's just going to be 0 is less than or equal to 4. Well, let's see, is 0 less than or equal to 4? 0 is here, 4 is there. Yeah, that's true. 0 is less than 4. So since that's true, that means that the origin 0, 0 is a solution. So I want to shade that side of the boundary line because that's where all of the solutions are, on the side that contains 0, 0. Don't think of it as above or below when it's in standard form. We just think of it as having the side that has the solution on it. We just test a point. All right, so that's how we graph in standard form. You graph your line by finding the x and the y intercepts. You make sure to graph the correct type of line, whether it's solid or dashed. And remember, it has everything to do with the little equal to bar on the inequality. We draw a solid line if it has the equal bar underneath, or a dashed line if it does not. Then test a point like 0, 0 or the origin to see if that's a solution or not, and shade the side that contains all of the solutions.